Hello, hello, is this working? Hey, looks like it is. Let's go, boy. Alright, gotta get these chats opened up, gotta get them running. Doubt we'll get anybody here today, but it doesn't bother me any. Alright, Twitch is working. Good to see. How about you two? Oh, hey, Sorbet. Nice to see you. We're doing something really cool today. I did finish off, sorry. Every time I speak, comes through my mic again. That is very disruptive. We're doing something really cool though. We started a project accepting command line arguments is all we got through too, but we're building an IO command line program. Very unique thing. Nobody's ever done it before. Okay. I'm just gonna wait a few moments, but then I think I'm just gonna start up. Hopefully y'all are doing well, doing good. Right, where were we exactly? We were going to Rust for Lemmings inside of the. Oh, very glad you read that before. Would have been ashamed to miss out on that. Where were we? Minigame. Here we are. Glad that got fixed. Right. We don't have a lot done in here. We don't have a lot in here either. So we are going to be building a project out quite big. If you wanted to get set up, all you really need is a main.rs file with the following pieces in it. I think that's literally everything that we have so far. Of course, you can just listen along. Okay, okay. God damn, it's hot in here. Gonna be a bit scatterbrained because it is like 34 degrees or something like that. That's pure guess. I don't actually know. Very warm for a Canadian. We are currently negative 11. Why does it say stuff like that? Negative 7 seconds into the stream? Like, what? As a web developer, I have no idea where they're getting that from. L? Okay, so let's start this. Reading a file. Now, we'll add functionality to read the file specified in the file path argument. First, we need a simple sample text file to test it with. We'll use a file with a small amount of text over multiple lines, with some repeating words, listing 12-3 as an Emily Dickinson poem that will work well. Create a file called poem.txt at the root level of your project. Alright, what is this called? Poem.txt? That's not a word. .txt. Let's increase the size of this. Make sure people can actually read this. And here is the actual poem. I'm not in Instagram. I'm just going to read this out. Make sure we got this. I'm nobody. Who are you? I'm nobody. Are you nobody too? Then there's a pair of us. Don't tell. They banish us, you know. How dreary to be somebody. How public, like a frog. Do tell your name to the livelong day. To an admiring bulb. I have no idea what this means. Cool poem. Is there supposed to be a space at the end? I guess there is. We're going to have to read that as well. All right. With the text in place, edit source/main.rs and add the code to read the file. as shown in 12.4. Alright, so we're going to have a let it contents. Oh yeah, I completely understood it first try. Right, so from the file system, we are going to read to string the file path. Okay. And it did automatically for me bring this in, env and file system. However, if your LSP does not do that, you should do that yourself. We are finally utilizing file path, and it's going to stop yelling me about that. We're not using contents though, so still going to be a very angry boy. Alright, now we're going to be logging out the contents. Wow, very well done. Alright. What's wrong here? Oh, forgot the dot expect. That's quite a bad problem. And the message we are going to be writing is should have been able to write a file. Should have been able to read the file. If not, we break. Dot expect resolves the result variant that comes out, places the OK back into the contents variable. Alright, that should work, and I'm just going to assume with no more reading that if we cr, oh gosh, what was it? Cargo run -- with the first argument being the query. So query, let's just do GG. And the second one being the file path should be /home /m /restful_lemming /minigrip. So yeah, it is just a -- anything after this should work. Poem.txt. Aha, yeah, worked perfectly fine. Right, a little bit of a reminder for myself, anything after -- gets pushed back to the actual application. And it looks like this is working fine. Yes, we still have a warning that that query is not used. That is the current one. Alright. Next off, first we bring in the relevant parts of the standard library with a use statement. We need standard file system to handle files. In main, the new statement, file system read to string, takes the file path, opens that file, and returns standard IO result of type string. Of the first file's contents. Of the file's contents, there's no secondary file. After that, we again add a temporary print line statement that prints the value of contents after the file is read, so we can check that the program is working so far. Let's run this code with any string as the first command line argument, because we haven't implemented the search part yet, and the poem.txt file as the second argument. Alright, so this will work if we just run it without all of the full path. I assume? Okay, yeah, it does work perfectly fine. Will it take in home /restful_lemmings, so on and so forth? Ignore that. What was it? I don't see why it wouldn't, honestly. I'm just going to double check for myself to check for gotchas. Perfectly fine. Okay. And we should just get this, though they don't include the warning, which is brought out inside of the right here. Am I not supposed to be getting this one? I assume we should be, but they're just truncating it. Right, the code read and then printed the contents of the file. The code has a few flaws. At the moment, the main function has several responsibilities. Generally, functions are clearer and easier to maintain if each function is responsible for only one idea. The other problem is that we're not handling errors as well as we could. The program is still small, so these flaws aren't a big problem, but as the program grows, it'll be harder to fix them cleanly. It's good practice to begin refactoring early on when developing a program, because it's much easier to refactor small amounts of code. We'll do that next. Okay, onward. Refactoring to improve modularity and error handling. To improve our program, we'll fix 4 problems that have to do with the program structure and how it's handling potential errors. We have 1, 2, 3, 4, 5 lines of code and 4 errors. Wow, that's good for us. First, our main function now performs 2 tasks. It parses arguments and reads files. As a program grows, the number of separate tasks the main function handles will increase. As a function gains responsibilities, it becomes more difficult to reason about, harder to test, and harder to change without breaking one of its parts. It's best to separate functionality so each function is responsible for a singular task. This issue also ties into the second problem. Although query and file path are configuration variables to our program, variables like contents are used to perform the program's logic. The longer main becomes, the more variables we'll need to bring into scope. The more variables we have into scope, the harder it'll be to keep track of the purpose of each. It's best to group the configuration variables into one structure to make their purpose clear. I agree with that. I'm glad that they bring this into that they show this, and we just don't have a bunch of random variables whose purpose is unclear. People are still going to do it. I doubt they've gotten 12 chapters into this book. The third problem is that we've used expect to print an error message when reading the file fails. But the error message just prints, should have been able to read the file. Reading a file can fail for a number of reasons. For example, the file could be missing, or we could not have permission to open it. Right now, regardless of the situation, we'll print the same error message for everything, which wouldn't give the user any information. Fourth, we use expect repeatedly to handle different errors. And if the user runs our program without specifying enough arguments, they'll get an index out of bounds error from Rust that doesn't clearly explain the problem. It would be best if all error handling code were in one place, so future maintainers only had to go to one singular place and consult the code for error handling logic needed to change. That was not what was written down. Best to have one place that everybody who wants to fix an error handling issue can go to one singular place. Having all the error handling code in one place will also ensure that we're printing messages that will be meaningful to our end users. That is strange. I don't think I've ever been in a larger project that does separate error handling out into its own function. No, I really can't think of any. I've been in a few which have error handling for one small section being put into a separate file within that project's directory, but I've never had every bit of error handling being placed into one module or one singular place. That is a strange thing. That's an oddity. I'm open for it, though. Separating our concerns for binary projects. The organizational problem of allocating responsibility for multiple tasks in the main function is common to many binary projects. As a result, the Rust community has developed guidelines for splitting the separate concerns of a binary program when main starts getting large. Process of the following steps. Split your program into a main.rs and a lib.rs and move your program's logic to lib.rs. As long as your command line parsing logic is small, it can remain in main.rs. When the command line parsing logic starts getting complicated, extract it from main.rs and move it to lib.rs. Okay. The responsibilities that remain in the main function after this process should be limited to the following: calling the command line parser logic with the argument values, setting up any other configuration, calling a run function in lib.rs, handling the error if a run returns an error. Okay, so main is like a controller, whereas the lib.rs is the model in view. This pattern is about separating the concerns. Main.rs handles running the program, and lib.rs handles all the logic of the task at hand. Because you can't test the main function directory directly. This structure lets you test all of your program's logic by moving it into functions like lib.rs. The code that remains in main.rs will be small enough to verify its correctness by reading it. Let's rework our program by following this process. Not procedure, process. Sorry about that. Extracting the argument parser. We'll extract functionality for parsing arguments into a function that main will call to prepare for moving the command line parsing logic to source/lib.rs. Listing 12.5 shows a new start of main that calls a new function, parseConfig, which we'll define in source main.rs for the moment. Okay. We are using... Alright, so after this point, we are simply going to let a tuple containing query and file path equal parseConfig, and we are going to pass in a reference to the arguments, borrowing arguments as we do. Okay, next we are going to create a function called parseConfig, taking in args, which is a reference to a list of strings. Where is that button? Fantastic. Of type string. Afterwards, we have a return type of a tuple containing two reference strings, or string slices. Wow, typing is a difficulty for me apparently. Alright, there we go. We'll let query. We're just moving in this section to here. Just a moment, I'm going to clear my clipboard. I don't want to accidentally paste out something I shouldn't. Sorry about that. Afterwards, we are simply going to be returning a tuple containing the two pieces. Okay. I believe this should work as before. Let's just check. Ensuring that it works, it does not. Why not? Because I have misspelled file path. And it works fine. Fantastic to see. We're still collecting the command line arguments into a vector, but instead of assigning the argument value at index 1 to the variable query and the argument value at index 2 to the variable file path within the main function, we pass the whole vector to the parseConfig function. ParseConfig function then holds the logic that determines which argument goes in which variable and passes the value back to main. We still create a query and file path variable in main, but main no longer has the responsibilities of determining how the command line arguments and variables correspond. This rework seems like overkill for such a small program, but we're factoring in small, incremental steps. After making this change, run the program again to verify it still works. It's good to check your progress often. This helps identify errors and fix them as they occur. Oh, you're back! Welcome! You have been missed. I didn't know you were gone. I'm sorry for that. So far we've just taken all the argument parsing into a new function, simply moving all the junk from main into a separate function here. It's telling us how, hey, this isn't exactly a large quantity of content to move in, but even if it isn't, as our program grows, it'll gain larger amounts of space. That was not a good explanation. You're welcome. Right? Grouping configuration values. We can take another small step to improve the parseConfig function further. At the moment, we're returning a tuple, but then we immediately break that tuple into two individual parts. This is a sign that perhaps we don't have the right abstractions yet. Yeah, it probably is. I really am sorry I haven't had a lot of time on my hands. I really want to get back into that, though. Hey, if you've read it, you now know it, and I'm glad you have. What I'm assuming here, though, is that we are going to separate it out into a struct, like the struct you made for Cliff 2, or CLI-FF. Right. Another indicator that shows this. Wow, words are a difficulty. Another indicator that shows there's room for improvement is the config part of parse config, which implies that two values we returned are related and are both part of one configuration value. That's not currently conveying this meaning. We're not currently conveying this meaning in the structure of the data other than by grouping the two variables into a tuple. We'll instead put the two values into one struct and give each of the struct fields a meaningful name. Doing so will make it easier for future maintainers of this code to understand how the different values relate to each other and what their purpose is. Yes, I'm right, yep. Fairly obvious what we're going to be doing, but there's a lot more code here. I wonder why they put it down here. I strongly disagree with that, and I'm going to behave differently. I'm going to put my struct up top. So if you've already seen a lot of this is going to be rather boring for you. Sorry, Sir Bay. Always good to look back at what you've already learned, though. So it's just simply a query of type string and a file path of type string within the struct config. And that's really the only change, except for, of course, taking in the config, passing back instead of a tuple, a config. And of course, well, that's actually it, isn't it? Well, no. We're going to want to take in something called conf. Likely? What do they call it? They're just calling it config. And file path will be config.filepath, I believe. Yes. And it should still work at this point too. No, it will not. Why will it not? Yes, config by defined here. What's wrong with this? Expected function, tuple, or tuple variant found config. I don't understand. Is the issue legitimately that I've put it here? Let's minimize difficulties here. Likely going to be something incredibly dumb. What is the problem? Oh, I see. I see. Yep. Oh, thank you for that. Should have read that, should have read the comment there. Mismatch type, expected string, found reference string. Why is that an issue? These are reference strings. Oh, we are cloning. This is what happens when you don't read. We are cloning both of these, and it's no longer a reference. Wonder why? Well, yeah, we don't want a reference inside of our config table. Makes sense. Again, thank you for helping me out there, Sorbet. I wish I had read it previously. Would have saved me some time. We've added a struct named config, defined to have fields named query and file path. The signature of parse config. Now, well, before we do that, let's run this one more time to ensure that it does work. Sorry about that. The signature of parse config now indicates it returns a config value. In the body of parseconfig, where we used to return string slices that reference string values in args, we now define config to contain own string values. The args variable in main is the owner of the argument values and is only letting the parseconfig function borrow them, which means we'd violate Rust borrow rules if config tried to take ownership of the values in args. Okay. If config, as in the name of the struct, not the actual. Is this an issue? Is this are they writing this incorrectly? Because this would be the name of the struct. That's the struct type, whereas the ownership should be within let config. Correct? Config needs to own this stuff. I don't really understand what it's saying. Perhaps it's talking about this in reference to it being some type of a. No, I really don't understand. This must be. I'm just going to put a note here. Is this a typo? Shouldn't the variable named config in main own? I believe that's what they're trying to say, but this does have a separate meaning. Right, the args variable in main is the owner of the arguments variable and is only letting the parse. Yep. Which means I guess I really just don't understand ownership enough, or this is an issue. I do understand. I don't know enough about ownership nor comprehend it completely, so that is a very big possibility. There are a number of ways we can manage the string data. The easiest, though somewhat inefficient, route is called the clone method. Is to call the clone method on the values. This will make a full copy of the data for the config instance to own, which takes more time and memory than storing a reference to the string data. However, cloning the data also makes our code very straightforward, because we don't have to manage the lifetimes of the references. In this circumstance, giving up a little bit of performance to gain simplicity is a worthwhile trade-off. Very true, I'd agree. The trade-offs of using clone. There's a tendency among many Rustaceans to avoid using clone to fix ownership problems, because it's a runtime cost. Chapter 13, you'll learn how to use more efficient methods in this type of situation. But for now, it's okay to copy a few strings to continue making progress, because you'll make these copies only once, and your file path and query string are very small. It's better to have a working program that's a bit inefficient than to try to hyper-optimize code on your first pass. There's a saying about this, but I can't remember. As you become more experienced with Rust, it'll be easier to start in the most efficient situation. To start with the most efficient solution. But for now, it's perfectly acceptable to call clone. Premature optimization, that's the word for it. We've updated main, so it places the instance of config returned by parse config into a variable named config. And we updated the code that previously used the separate query and file path variables, so it now uses the fields on the config struct instead. Now our code more clearly conveys that query and file path are related, and that their purpose is to configure how the program will work. Any code that uses these values knows to find them in the config instance, in the fields named for their purpose. Creating a constructor for config. So far, we've extracted the logic responsible for parsing the command line arguments from main and placed it in the parseconfig function. Doing so helped us to see that the query and file path values were related, and that the relationship should be conveyed in our code. We then add a config struct to the name. We then added a config struct to name the related purpose of query and file path, and to be able to return the values named as struct field names from the parseconfig function. So now that the purpose of the parseconfig function is to create a config instance, we can change parseconfig from a plain function to a function named new and is associated with the config struct. Making this change will make our code more idiomatic. You can create instances of types in the standard library, such as string, by calling string : new. Similarly, by changing parseConfig into a new function associated with config, we'll be able to create instances of config by calling config : new. I say this is a bit overkill, honestly. All right, so we are simply going to impl on config, and then take in all of this. But we are going to change the name to new. Oh, oops. Wow, I'm really good at this, ain't I? Yeah, I'm really good at this, ain't I? There we go. Try and be quicker, but in fact, I am much, much slower. All right, let's just check. Yeah, that's all they're doing. New here, but now we need to, of course, change this. Config equal config new. Oops. All right, so that's capital C config, colon new. That's about it. I don't see any differences other than that. Let's just run it to ensure. Yep, looks fine to me. We've updated main where we were calling parseConfig to instead call config new. We've changed the name of the parseConfig to new and moved it into an impl block, which associates the new function with config. Try compiling it again and make sure it works. Sure does. Fixing the error handling. Now, we'll work on fixing our error handling. Recall that attempting to access the values in the arg vector at index 1 or index 2 will cause the program to panic if the vector contains fewer than 3 items. Try running it without any arguments and it'll look like this. I'm gonna trust them that it'll say main panicked, index out of bounds, the length is 1, but the index is 1. The line index out of bounds, the length is 1, the index is 1, is an error message intended for programs. It won't help our end users understand what they should do instead. Let's fix that now. In listing 12-8, we add a check in the new function that will verify that the slice is long enough before accessing index 1 and 2. If the slice isn't long enough, the program panics and displays a better error message. Right? So inside of our new function, we are going to simply ask if arg snow length is less than 3. We want to panic, stating, hey, not enough arguments. I'd argue you should also say expects 3. Expects 3, or expects 2. Sorry, expects 2 got and the number, but I'm not going to put in the number here. That's what you should be doing. In a different... Yeah, you did this in CLI-FF? In a different way, obviously. Oh, you're talking about the error handling, or separately the config new? I'm glad that I'm able to refresh your memory, though, no matter what. God, I gotta read that code. I'm really excited to see how it's gone along, and I really want to start helping out again. Right. This code is similar to the guess new function we wrote in listing 913, where we called panic when the value argument was out of range of valid values. Instead of checking for new yeah, the error display? Yeah. Human error. Human error. Get better. When the value argument was out of the range of valid values. Instead of checking for a range of values here, we're checking that the length of args is at least 3, and the rest of the function can operate under the assumption that this condition has been met. If args has fewer than 3 items, this condition will be true. And we call panic macro at the end of the program, and end the program immediately. With these extra few lines of code in new, let's run the program without any arguments again. See what it looks like. Alright, this should just break. Tell us, hey. Nope. What? Oh, argy. Wow. Talking about human error. Not enough arguments, expect us to. Okay. With these few lines of code in the new, yep, let's run the program. The output is better. We now have a reasonable human error message. However, we also have extraneous information we don't want to give to our users. Perhaps using a technique we used in listing 913 isn't the best to be used here. A call to panic is more appropriate for a programming problem than our problem. As discussed in Chapter 9, instead, we'll use the other technique you learned about in Chapter 9. We are going to be returning a result. I'm just going to assume we will be returning a result. No, they've got a lot of text here. There's probably a bit more discussion on whether or not, or how this should be built. We can instead return a result value that will contain a config instance in the successful case and will describe the problem in the error case. We're also going to change the function name from new to build, because many programmers expect new functions to never fail. When config : build is communicating to main, that is a terribly written sentence. When config : new is communicating to main, we can use the result type to signal there was a problem. Then we can change main to convert an error variant into a more practical error for our users without the surrounding text about thread main and Rust backtrace that a call to panic causes. Lesson 12.9 shows the changes we need to make. We need to make to the return value of the function. We're now calling config : build, and the body of the function needed to return a result. Yeah? That is what you should do. It's a lot better. Right? So we're just having a result, expecting either a config or a reference to static error. No, to a static string. For the generic lifetime. Status. Wow. Is there an issue here? Is that not a comma? Oh, I see. Yep. And here we are going to return error. I thought it was result and within that being error, but no, it's not. Well, let's just bring back what we had here. Oh wait, I should still have that in the buffer somewhere. Where is that? Shame. I guess not. Not enough errors. Could have more errors. Okay. Otherwise, we want to return an OK variable with the config inside of it. Separately, we should change this to build. and have contents, we are no longer going to have the expects at all. We don't need that. What is this? Oh, never mind. Yep. We're not touching that yet. We're now going to be build, passing in the args, and this will not work because we need to handle the air. How exactly are we going to be handling the air? I guess we will see. I'm going to assume we're just going to match on the OK or error, output some string, and end the application afterwards. Our build function returns a result with a config instance in the success case and a static string in the error case. Yep. Our error values will always be string literals that have the static lifetime. We've made two changes in the body of our function. Instead of calling panic when the user doesn't pass enough arguments, we now return an error value, and we've wrapped the config to return and an OK. This changes the function. Make the function conform to its new type of signature. Returning an error value from config build allows the main function to handle the result value returned from the build function and exit the process more cleanly in the error case. To handle the error case and print a user-friendly message, we need to update main to handle the result being returned by config build, as shown in listing 1210. We'll also take the responsibility of exiting the command line tool with a non-zero error code away from panic. Instead, implement it by hand. A non-zero exit status is a convention to signal the process that called our program that the program exited with an error state. Okay. Yep. We'll have an unwrap or else here. I would have used a regular match, but yeah, unwrap or else is the better solution. It's something that I'm always going to forget happens. All right. Error. Print line. Problem parsing arguments. Passing in the argument. Sorry, the error. Then separately, we're going to process dot exit. Sorry. Method exit with the code of 1. Expect a config found something else. What? Where did this come from? Yeah, that's fine. What is the problem here? Unwrap or else, bringing in error, print line, problem occurred with the error here. Config build, taking in args, dot or wrap, unwrap or else. What is the issue? I really don't know. Let's just take this. Delete this. Put it in. Failed to resolve. Use of undeclared crate or module process. Oh, okay. Yep. You see, you should be reading error codes. Sometimes they're quite helpful. Okay, that worked. Let's see if we fail correctly. Nope. Nope, yep, we do. Yeah, I got that in the end. Sorry about that. Must have been quite frustrating to see. Okay. So that does work, but we also get all of the compile stuff, including the warning. We just took that out. there would be no issue. Or if we used it somewhere, there would be no issue. All right. In this listing, we've used a method we haven't covered in detail yet, unwrapperElse, which is defined on result DE in the standard library. Using unwrapperElse allows us to define some custom, non-panic error handling. Yeah, no worries, Sorbet. Always happy for your help. And I am sorry for the lag. I wish this was a lot quicker. If the result is an OK value, the method's behavior is similar to unwrap. It returns the inner value OK is wrapping. However, if the value is an error value, the method calls the code in closure, which is an anonymous function we define and pass as an argument to unwrapperElse. We'll cover closure in more detail in Chapter 13. For now, you just need to know that unwrapperElse will pass the inner value of error, which in this case is the static string not enough arguments that we added in listing 12.9 to our closure in the argument error that appears between the vertical pipes. The code in the closure can then use the error value when it runs. I am curious if you've learned anything about closures. I've been seeing the syntax some places, but I really don't understand what it's doing. I'm a web developer. I mean, it probably exists in the web world, I've just never ran into it. I am very curious about it, though. We've added a new use line to bring process from the standard library into scope. The code in the closure that will be run in the error case is only 2 lines. We print the error value and then call process exit. The process exit function will stop the program immediately and return the number that was passed as the exit status code. You use map error in this section? Yeah, that would be a good one, yeah. This is similar to panic-based handling we use in 12-8, but we no longer get all the extra output. Let's try it. So you use map error instead of unwrapperElse, and map error, I don't believe it uses the closure. I really want to know what's going on. Yeah, this will work, giving us all the compile information, of course. Extracted logic from main. Extracting. Now that we've finished refactoring the configuration parsing, let's turn to the program's logic. As we stated in separation of concerns for binary projects, we extract a function named run that will hold all the logic currently in main that isn't involved with setting up configuration or handling errors. When we're done, main will be concise and easy to verify by inspecting. Oh, map error does use the closure thing. I wonder why one would be used over the other. I'll admit, I thought I knew what map error was, but I don't really. I'll have to look into that, though. When we're done, it'll be concise and easy to verify by inspection, and we'll be able to write tests for all other logic. Listing 12.11 shows the extracted run function. For now, we're just making the small incremental improvements of extracting the function. We're still defining the function in source main.rx. Right. This is extracting a run function containing the rest of the program's logic. All right, yep. So here we have allow contents and printing this line. That's all going to go into a new function called run. Config, thinking in something of type config, and doing exactly what we did previously. We are then just going to run with the config here. This is really quite similar to something like an MVC model. Model view controller, except we only have the models and controllers. The models are currently in functions and main being the controller. I really love that style of work, so I'm glad that this is a normal thing. Right, does this still work? Looks like she does. Right. The run function now contains all the remaining logic from main, starting from reading the file. Okay? The run function takes the config instance as an argument, returning errors from the run function. Right? With the remaining program logic separated into the run function, we can improve the error handling as we did with contain, config, build, and listing 12 none. Instead of allowing the program to panic by calling expect, the run function will return a result type error. When something goes wrong, words are a difficulty for me right now. I am not doing very well at reading this fairly simple sentence. The run function, it will return a result when something goes wrong. This will let us further consolidate the logic around error handling into main in a user-friendly way. Listing 1212 shows the changes we need to make to the signature and body of run. That was a task, seriously, my lord, I did not do very well there. Right, now I am just going to pop this down to a new line so that it's a lot more readable. I'm not allowed to do that with the program I normally do. Alright, lastly, we are going to add in error. Okay, inside of our function run, we are going to be returning a result. Inside of this result, yeah, I definitely agree. Inside of this result, we will have a empty tuple, can't remember what that is, I guess any type, box of a dynamic error. That is the error, to allow us to put any error out towards the user. Okay. Lastly, we are going to output an OK with nothing inside of it. You're in the woods and lagging? You're watching coding videos in the woods. Why are you the coolest person I've met? Damn. Not a worry if you have to drop out. The woods are a more important thing than this. Good luck there. Find a cool mushroom. I love mushrooms, especially morels. Okay. We no longer need this, do we? No, we don't, because of the style that we are using. Okay, I believe that's it. Let's try running this again. Nope. I cannot help you. You are on your own. I fully believe in you. Oh. Okay. I see the problem. Read between the lines. I'm so sorry for you. I hope you're enjoying the woods, though. We've made 3 significant changes here. First, we changed the return type of the run function to result in a box with a dynamic error. This function previously returned the unit type nothing, and we keep that as the value returned in the OK case. For the error type, we use the trait object box dynamic error that we brought in with standard error into the scope. The standard error is that you're back? Congrats. Okay, I see where I messed up. I mean, we could do that, but I'm just going to be using. It's either you or it's the bear that stole your phone. Look, if you're a bear who stole Sorbet's phone, you gotta tell me, it's in bear law. Looks like that worked. We didn't do much, I just floundered about trying to put in this. We've made 3 significant changes here. First, we changed the return type of the run function to result. Oh, I've already read that. For the error type, we'll use the trait object box dynamic error we brought in via that use method into scope with a use statement at the top. We'll cover trait objects in chapter 17. For now, we just know that the box dynamic error means the function will return a type that implements the error trait, but we don't have to specify what particular type the return value will be. This gives us flexibility to return error values that may be a different type in different error cases. The dyne keyword is short for dynamic. Second, we've removed the call to expect in favor of the question operator, as we talked about in chapter 9. Rather than panic on an error, question mark will return the error value from the current function for the caller to handle. Third, the run function now returns an OK value in the success case. We've declared the run function success type as blank in the signature, which means we need to wrap the unit type value in the OK value. This OK syntax might look a bit strange at first, but using blank tuple like this is the idiomatic way to indicate that we're calling run for its side effects only. It doesn't return a value that we need. Okay, that's very kind of you, thank you. You're gone now. We don't need you. That was not kind of them. Where were we now? I've lost my place. That was incredibly unkind, honestly. It should be ashamed. That's not the place. That's the place. Yep. Third, the run function now returns, yes, we have read that. When you run this code, it will compile, but will display a warning. Right? Did it? I didn't see that. I should have read it. Let's read it here, because it's nice and pretty. Right, field query is never used. Did you unused result? That must be used. Is that the error that it's looking for? Unused result that must be used, yes. Run config. This result may be an error variant, which should be handled. Note, warn unused must use on by default. Use let underscore equal to ignore the resulting value. Okay. Rust tells us that our code ignored the result value, and the result value might indicate an error occurred, but we're not checking to see whether or not there was an error. And the compiler reminds us that we probably meant to have some error handling code here. Let's rectify that problem now. Handling errors returned from run in main. We'll check for errors and handle them using a technique similar to one we used with config build in listing 12.10, but with a slight difference. Okay. Side of main, we are using the iflet. Iflet error e equal the result of config colon build. So, okay, wrong place. Wow, really great stuff, man. Now I'm blocking out the YouTube chat. What if there's some strange child wanting to learn about Rust? Here we go. Iflet error of type E. Sorry, not of type E. Well, error being passed in E equal run. We already have that. Fantastic. Print application error. Oop. Why are there two there? I don't know. Application error passing in E. Display to user. Then we exit with status code I. Sorry, 1. Fantastic. That'll likely still work. She does. Let's check to see if the next one will work, or if it'll work now. Yep. So we've confirmed that it still works. We have an if let error, which will simply output the error within the variable e. And if that error exists, it'll print an application error message and then exit with code 1. We use if let rather than unwrap or else to check whether run returns error value and call process exit if it does. The run function doesn't return a value that we want to unwrap in the same way that config build returns the config instance. Because run returns nothing. In the success case, we only care about detecting an error, so we don't need unwrap or else to return the unwrapped value, which would only be nothing. The bodies of the if let and the unwrap or else function are the same in both cases. We print the error and exit. Splitting code into a library crate. Our mini-grit project is looking good so far. Now we'll split the source main.rs file and put some code into the source lib.rs file. That way we can test the code and have a source main.rs file with fewer responsibilities. Let's move all the code that isn't the main function from source main.rs into source lib.rs. The run function definition, the relevant use statements, the definition of config, the config build function definition. Constants of source lib.rs should have the signatures shown in listing 1213. We've omitted the bodies of the functions for brevity. Note that this won't compile until we modify source main.rs in listing 1214. Alright, let's create a new file which we will call lib.rs, /source lib.rs. And inside of it, we are going to be placing all of our junk. We will need I believe we'll just need error. Yeah, it's right there. I guess we only really need error and file system. So far it states. Right, so we want to bring in the struct. We want to bring in the config. We want to bring in run. Okay. Wow, that's really great. Why won't you work? Do the thing, Vim. Do the Vim thing. There we go. Oh, and this got put all the way to the bottom. All right. It should be good. File not included in module tree. Yep, no it isn't. Okay, I believe that's everything we needed to do here. Looks good. We've made liberal use of the pub keyword on. Yep, I forgot about that. Yep, we want publics for everything because everything is being used elsewhere. Public config, public run, and the struct should be public as well because we are going to be using this everywhere. Nope, we don't need that. Not there. This will need it though. Okay. That's just a bunch of warnings stating that it's never been used. I think that's everything that we need to do. We've made liberal use of the pub keyword on config, on its fields and its build method, and on the run function. We now have a library crate that has public API we can test. Now we need to bring the code we moved from source/lib.rs into scope of the binary crate in source main.rs, as shown in listing 12.14. Okay, you're simply going to use, I don't need this now, right? No, we do? Who knows? We'll see soon. Yeah, env and process are the only thing we need. Top of course, the new thing we have, minigrep. Bringing in config. Fantastic. We have the iflet, which we need to bring from minigrep. Here. Also, is that it? That could not be it. Sure, let's check it out. Yeah, she works. Perfectly fine. Well, that was rather simple. If I remember correctly, the entirety of CLI-FF is within a single block of main. Breaking that apart is going to be a very, very interesting process. We add a use minigrep config line to bring the config type from the library crate into the binary crate scope. And we prefix the run function with our crate name. Now, all the functionality should be connected and should work. Run the program with cargo run to make sure everything works properly. That's a good point. Let's just make sure that the air handling works too. Woo, that was a lot of work. But we've set ourselves up for success in the future. Now, it's much easier to handle errors, and we've made the code more modular. Almost all of our work will be done in source lib.rs from here on out. Let's take advantage of this newfound modularity by doing something that would have been difficult with the old code, but easy with the new. Write some tests. Okay, well, we just got through that, and we're going into developing the library's function with test-driven development. It looks to be a fairly long piece to go through, but we got another hour to go past it. I may have to stop halfway through. It depends on if I get a text or not. Apologies, I kind of had to fight to get this 2-hour period freed up, but we truck on. Forward. Developing the library's functionality with test-driven development. Now that we've extracted the logic into source lib.rs and left the argument collecting and error handling in main.rs, it's much easier to write tests for the core functionality of our code. We can call functions directly with various arguments. And check return values without having to call our binary from the command line. In this section, we will add the searching logic to the minigrep program using test-driven development, using the test-driven development process with the following steps. Create a test that fails and run it to make sure it fails for the reason you expect. Write or modify just enough code to make the new test pass. Refactor the code you just added or changed to make sure the tests continue to pass. Repeat from step 1. Though it's just one of many ways. Goodbye, we are deleting you. You are gone. You are unnecessary. In fact, we hate you. Though that is just one way to write software, TDD can help drive code design. Writing the test before you write the code that makes the test pass helps to maintain high test coverage throughout the process. Well, test drive is back. Why is it back? You should be gone. Goodbye. Goodbye. Thank you. Right. Writing the test before. Yep. We'll test drive the implementation of the functionality that will actually do the searching for the query string and the file contents and produce a list of lines that match the query. We'll add this functionality in a function called search. Writing a failing test. Because we don't need them anymore, let's remove the printline statements from source lib.rs and main.rs that we use to check the program's behavior. Then, in source lib.rs, add a test module with a test function, as we did in Chapter 11. The test function specifies the behavior we want the search function to have. It will take a query and the text to search. It will return only the lines from the text that contain the query. Listing 1215 shows this test, which won't compile it. Alright, let's remove everything with a print line here. Right. Delete it here. Delete it here. Delete it here. Right. Right. I believe that is everything. Yep, she is. Good stuff. Right, so now at the end here, we are going to add in a tag with CFG test. The module will be called, sorry, just a moment. There we go. The module will be called test. And inside it, we will use super. Bring everything into context. We will have a test. Annotated there. Here's a function. One. Result. Asking for let query equaling dot. Why are you doing that? That is not what we want. That's obviously not what I wanted. Stop that. Wow, I'm doing really good today. Right, within this function, we have dot. Letting contents equal nothing. Oh, never mind. We have more than nothing. Inside of here, we have Rust, safe, best, productive, pick3. I don't know what pick3 means. Okay. Just two unused variables so far. Now we are going to assert that it is equal a vector with safe, fast, and productive. From search, bring in query, and contains, and content. Oops. I believe that's fine. What's wrong? That's what's wrong with this. Okay. The vector is ending here. I see. Expected closing delimiter. Oops. What is going on? I see. Yep. I don't know why I did that. What's going on here? What did I mess up now? Come on. All right, we gotta have another one of these. That should work. What? Okay, I really fucked up here. Unexpected closing delimiter here. What? Okay, yeah. That is correct. That is not correct. Found it. Okay. Why was the error all the way up there? Okay, there we go. And search does not exist, so this will fail. Thank God. Is that it? That is it. Wow. That was embarrassing. This test searches for the string duct. The text we're searching is 3 lines, only one of which contains duct. Note that the backslash after the opening double quote tells Rust not to put a new line character at the beginning of contents of this string literal. We'll assert that the value returned from the search function contains only the lines we expect. We aren't yet able to run this test and watch it fail because the test doesn't even compile. The search function doesn't exist yet. In accordance with TDD principles, we'll add just enough code to get the test to compile and run by adding the search function that always returns an empty vector. As shown in listing 1216, the test should compile and fail because an empty vector doesn't match a vector containing the line safe, fast, productive. Okay? Yep. So, at the top of this, or I guess at this point I would personally put it, we'll put a public function called search with a default lifetime with an annotated lifetime hello of A. That is not what I want. A query taking in a reference string, contents, which is a reference. This is not just enough to get it to work. This is, in fact, quite a lot more than we need to get it to work. This breaks TDD. This is not. We wouldn't put in any of this information if we were just doing straight out TDD. This would happen in a few moments after we ran and saw that it does, in fact, fail. Personally, I would write all this code myself. It's just I have been yelled at for writing this code previously. Oh. Turning a vector, which is empty. Right, what did I mess up? A lot. What? Query is a reference string. Contents is a reference string with a length of A. Vector is a reference string. That's the same code, is it not? Let's see where I fucked up. I did fuck up. Wow. Where did I fuck up? Query string contents. Somewhere. Where did I fuck up? I legitimately just don't see it. I legitimately simply don't see it. It must be somewhere around here. Because of reasons. Right, this is all the same thing. Contents, colon, reference, A. This seems to be where it's messing up. Is this the correct? Oh, I see. I'm using a... Yep. Thank you, Magel. Welcome in. Look, this is not the most embarrassing thing I've done today. You are very correct. Thank you for that. Anyway, very, very happy to have you, Magel. I'm sorry to have summoned you with my stupidity. I appreciate you being here to help me out, though. I'm just going to continue. Again, thank you for joining us. Notice that we need to define an explicit lifetime A in the signature of search and use that lifetime within the contents argument and return a value. Recall in Chapter 10 that the lifetime parameters specify which argument lifetime is connected. Only reckon I saw it because I do the same thing an annoying amount of the time. Oh god, this is going to be a continual issue for me. I'm going to write a configuration in my Vim config to change all backticks into single quotes. Maybe that'll force me to remember. I did that with a few things in Python. Recall in Chapter 10 that the lifetime parameters specify which argument lifetime is connected to the lifetime of the return value. In this case, we indicate that the return vector should contain string slices that reference slices in the argument contents, rather than the argument query. In other words, we tell Rust that the data returned by the search function will live as long as the data passed into the search function in the contents argument. Will live as long as the data in that placement. This is important. The data referenced by a slice needs to be valid for the reference to be valid. If the compiler assumes we're making string slices of query rather than contents, it will do its safety checking incorrectly. If we forget the lifetime annotation and try to compile this function, we'll get this error. This is one of the main reasons a lot of people love Rust. It has very good errors. Let expected named lifetime parameter on the vector string. Help, this function's return time contains a borrowed value, but the signature does not say whether it is borrowed from query or contents. Help, consider introducing a named lifetime parameter, and it gives you the same code we wrote, except we didn't put it into query, because query doesn't need to live for that long. We're not passing anything back directly from query. Rust can't possibly know which of the two arguments we need. So we need to tell it explicitly, because contents is the argument that contains all of our text, and we want to return the parts of that text that match. We know contents is the argument that should be connected to the return value using the lifetime syntax. Other programming languages don't require you to connect arguments to return values in the signature, but this practice gets easier over time. You might want to compare this example using the Validating References with Lifetime section in Chapter 10. Now let's run the test. Alright. Cargo test. Test failed. Fantastic. Test result failed. 0 passed, 1 failed. Looks fine. Test failed correctly. I'm not going to read this. We understand why it failed. Great, the test fails as we expected. Let's get the test to pass. Writing code to pass the test. Currently, our test is failing because we always return an empty vector. To fix that in implement search, our program needs to follow these steps. Iterate through each line of the contents. Check whether the line contains our query string. If it does, add it to the list of values we're returning. If it doesn't, do nothing. Return the list of results that match. Let's work through each step, starting with iterating through lines. Iterating through lines with a lines method. Rust has a helpful method to handle line-by-line iteration of strings, conveniently named lines. That works as shown in listing 1217. Note that this won't compile yet. Function search. With all of this, for line in contents.line, do something. Alright. We're not bringing anything in. This is just in the prepend. In contents. Not lines. Oh, it's in file system, of course. Alright, this will not compile. But Rust Analyzer can't tell us that it won't compile. The lines method returns an iterator. We'll talk about iterators in Chapter 13. But recall that you saw this way of using an iterator in 3.5. You think I remember 3.5? No. Where we used a for loop with an iterator to run some code on each item in the collection, searching each line for the query. Next, we'll check whether the current line contains our query string. Fortunately, strings have a helpful method named contains that does this for us. Add a call to the contains method in the search function as shown in listing 12.18. Note this still won't compile yet. Okay. Now if line dot contains the query, do something. Contains. Word hard. At the moment, we're building up functionality. To get it to compile, we need to return a value from the body as we indicated we would in the function's signature. Storing magic lines. To finish this function, we need a way to store the magic lines that we want to return. For that, we can make a mutable vector before the for loop and call the push method to store a line in the vector. After the for loop, we'll return the vector, as shown in 12.19. Right, let mutable results equal back new. It's just an empty vector. Good stuff. What's wrong here? What's wrong here? Time annotation needed for, well, I think that it'll probably be fun when we do this, right? Oops. Yeah. Okay. Personally, I prefer more explicitity. I wish that it would just tell you have to give it there. Instead of just the compiler telling you, hey. Instead of it erroring out in that situation. I do prefer the other way. Results. Now the search function should only Now the search function should return only the lines that contain query, and our test should pass. Let's run it. Failed. It failed. What did I do wrong here? Where exactly could it be? Oh, I see. I mistyped. That should work now. No, it doesn't. Let's just take this. Paste it out. And, well, this is going to be a very weird way of doing the thing that I was doing. Oh, I see why it didn't work now. Because of all this space. The indentation, sometimes reading your chat responses is probably going to help me out better than the weird things I do. You are correct. Yep, that worked. I did that on purpose because I hate it when code goes all the way down here, and then I forgot that is obviously going to be an issue. Look, this is a clown circus. This is what this stream is for. This is to watch somebody fail at coding. This is to cause frustration and difficulty in the people watching. You too? I hate it so much. It makes me so angry. I'm still going to fix it. I'm going to figure out a way. I think I know what to do. I'm going to put this all in one line, because that's helpful, isn't it? Actually, this is probably not going to do the thing that I want to do. But I'm still going to do it. Because I hate this so much. Yes. Yes, it is. It works. It works fine. That's actually so much nicer. It looks so much nicer. If it was 40 lines, I'd still do it. You couldn't stop me. But it's a bad way to do things. It's so bad. Wonder if Rust has an equivalent to Python's dedent? I've never heard of that. Fixing Python indentation? I'm gonna look that up. That sounds really cool. I kind of doubt it because they'd have to change compiler code if that would allow it. Well, no, maybe not. I don't know. I'd have to look. That is really interesting. I think I'm gonna look that up, Mabel. Right. Now the search function should be returning only the lines that contain query, and our test should pass. Our test passed, so we know it works. At this point, we could consider opportunities for refactoring the implementation of the search function while keeping the tests passing to maintain the same functionality. The code in the search function isn't too bad. dedent removes the indentation, so you can maintain clean indentation without these issues. That's good. I mean, it's possible. That would have to be in some like prepend type situation. So it would have to go through your code previous to it actually running. Be kind of hard, but I can't see why there wouldn't be a possibility of something like that happening. It'd have to be some program to run previously to edit your text, though, from my understanding. Unless you use some like intermediary, so it would be like dedent and then the text being put into it. Oh yeah, it could just be a macro. You're right. Yeah, something before the for the text. That's a good point. It's possible either it exists or it will exist soon because I'm gonna fucking make it if I ever have any time. The code in the search function isn't too bad, but it doesn't take advantage of some useful features of iterators. We'll return to this example in Chapter 13, where we'll explore iterators in detail and look at how to improve it, using the search function and the run function. Now that the search function is working and tested, we need to call search from our run function. We need to pass the config.query value and the contents that run reads from the file to the search function. And then run will print each line returned from search. If you're doing TDD, we should test this. But we're not really. We're line. All right. Now, what? Oh, I see what we're doing. I'm sorry. I thought we were just copy pasting the search functionality here. Okay, and we're passing in reference to config.query. Ah, they have it. I'm so glad. That makes me happy. What do they use? Is it like a, it doesn't look like it's a macro. It's definitely not a macro. Shame. I wish it was a macro. That would have been so much cleaner. But no, you gotta pass it into the dedent function. Yeah. That's okay, though. That's okay. I'm okay with that. If only we could, like, overload the, what is it called? This. If only we could overload the, quotation mark. Just force the functionality everywhere. Okay. How does it, I'm really curious, how does it understand how indented our code should be normally? Does it, oh no, I think I understand. It looks for the, lowest amount of indentation. It's literally just cleaning up the string menu. Yeah. I'm guessing if in the source, it looks for the, smallest amount of indentation and then just cuts it out from the start of every single line. Good though, that's cool. Okay, let's continue. That's going to be in literally every project I make that works with tests from now on, though. I didn't know that existed. That is such a terrible thing to do, though. Sorry to keep harping on this, but that is so terrible to bring in an entire dependency just to say I hate I hate the fact that I have to push in all of my text. That is such a weird thing to do. I love it though. We're still using a for loop to return each line from search printed. Now the entire program should work. Let's try it out. With our first word, it should return exactly one line from Emily Dickinson's poem, Frog. Should this work? Oh, I'm going to find so many random little things that are entirely broken, like this. What's happened here? Why is this now broken? What have I done? What? Oh, I've not finished writing the code. Wow. Wow. I got ahead of myself. Got ahead of myself by a mile. Alright, so we're bringing a reference to contents. Then we are printing all of the lines with the information inside of it. What? Print line. Use print line. There we go. Right? There's still an error somewhere. Does it help here? Does it help here? There's an error here. Mismatched type. Yep, of course there is. Yep. There we go. No errors. Let's see if this works. That's not what I wanted. Gotta go run. We are looking for frog. How public, like a frog. Right, we got two warnings. Unused variable air. And unused variable E. Okay, but it still works. It seems to be working. We're still using a yes. We'll look for frog and we'll get how public, like a frog. Coolio. Now let's try a word that will match multiple lines like body. Okay. We are looking for body. I'm often looking for a body. Alright, seems to work fine. And finally, let's make sure that we don't get any lines when we search for a word that isn't in the poem, such as monomorphization. I'm not going to type that out. Cup noodles. Nothing. You got nothing. Excellent. We've built our own mini version of a classic tool and learned a lot about how to structure applications. We've also learned a bit about file input and output, lifetimes, testing, and command line parsing. To round out this project, we'll briefly demonstrate how to work with environment variables and how to print to standard error, both of which are useful when you're writing command line programs. Okay, well, it's currently 9:09. We are 21 minutes out from the end. It seems to be an amount that we could do, but I think I'm going to leave for the day. Thank you both for being here, and anybody else who's currently watching. You are valid, and we love you. Or I love you. I don't know about Michael. He's a hateful person. Okay, I think this is going to be the end, though. Thank you all for joining me. I'm going to leave now.